So exercise 14D is from reviewing our trigonometric ratios. So this stuff is stuff that you should already know from previous years. So things like so, car, toa. I write a little bit weird just so we know what the fraction is. So obviously sine is O over H, cosine is A over H, and tan, is O over A. And we also need to know how to apply the understanding. So we know that sine is our y value, know that cosine is our x value. We also know that tan, just a reminder for those that don't remember, tan is equal to sine over cosine. Okay, so that's an identity that we'll be using in future as well. Any questions so far? No? Okay. So we know our sine, cos, tan in terms of our quadrants. So we have A, S, T, and C. Right. So making sure that you know how to find the certain lengths based on how to use your sine, cos, and tan. Do I have a question back there? I'm hearing quite a little bit of chatter there. No? Okay. If I've got, for example, a right angle triangle, and I've got theta over here, then we need to make sure we understand how to find different angles. So for example, if I've got 3 here and 8 there, you could use Pythagoras, but the idea is that we're looking for the unknown variable. In this case, we've been given theta. This is theta right there, bless you. This is theta right there, and we need to be able to find the value of theta. So what I go ahead is I find A, H, and O. I define those, right? So if this value is over here, the hypotenuse is which line? Yep, the diagonal looking one, perfect, it's the longest one, so I'm gonna write H over there. I've got adjacent as a line right next to the angle, which would be this one over here, and I've got O as the opposite. Now, I've got values for A and H, and I'm going through this quite quickly, I do apologize, but we've got A and H, and so we look back over here, which values or which formula has A and H? It would be this one right there. So we're using that one. I know that cosine of theta equals to A over H. In this case, 3 over 8. Okay? Now, you could do this by hand, or you can just put in your calculator and say that theta equals to inverse of cosine, or cos negative 1, of 3 over 8. Does that sound quite familiar to you guys? Yeah, you guys remember how to do that? So find the inverse of the trigonometric identity in order to find theta. Do you have a question up the back?
I was going to ask for the test. Is it non-calculator or calculator?
Good question. The test is non-calculator. I don't know why I said that like there was more. The test is non-calculator. Anything else? No? Okay. So being able to find that value over there. Now, if it's done by hand, then you need to be able to find this and just keep it as a exact value. So you wouldn't be expected to do any values that end up with decimals. Okay. Now, this idea applies to sine, cosine, and tan. I'm going to do a different example over here. Let's say I've got this there. That's not a right angle triangle. There we go. And let's say that's 25%. This value is obviously a right angle. I've got 5 and x over here. I'm going to do the same thing, identify with my A, H, and O's. So my adjacent would be this line, my hypotenuse is this line, and my opposite is this one. So once again, I'm using cosine. Can you guys see that up the back? Yep. So I'm still using cosine. So cosine of, now instead of writing theta, I know what the angle is. I'm writing 25 degrees, which gives me an A over H. So A is x over 5. So I can multiply both sides by 5 and I end up with 5 times cosine, or 5 cosine, 25 degrees equals to x. And then you can solve that by hand if you'd like. Any questions? No? So once you end up with this over here, typically we just put this into the calculator and then solve what you'd end up with for x. Alright, that's it for exercise 4D.